behalf of State Pollution Control Board, I welcome you all this morning. We would like to share with you that Bihar State Pollution Control Board has started one online training cum exposure series specifically on black carbon measurement as a tool for aerosol apportionment. We have been organizing so many lecture series, public awareness program for dissemination of information about environment. And of course, we are trying to join hands with academia, researchers, anyone who is working in the field of environment. So this endeavor is of the board is also in the same direction. And this exposure series, this is the first part of it, that is specifically on thermometer measurement and its application in aerosol apportionment. So we are starting this series on black carbon measurement with this first part on ethiometer measurement, and we are very happy, rather fortunate to have with us two eminent scientists working in this field, who has joined us online, Dr. Safi Hazar from IIT Dhanbad and Sri Mrinmoy Chakravarti from University of British Columbia, about whom we will talk, we will let you know a little later, and I'm sure many of you will be knowing him. So with the permission of our member secretary, sir, may I request you to present your welcome address for the benefit of the audience, sir. Please.
Very good day to all of you, because one of our esteemed speakers is from Canada. We are extremely happy to have Dr. Safi Hazar from IIT Dhanbad and Mr. Mrinmoy Chakravarti from University of British Columbia, Canada. So, in the outset, I would like to thank you for accepting our invitation and for joining us to deliver this speech today on black carbon measurement as a tool for aerosol apportionment. Also, on this occasion, some of our senior colleagues have also joined us physically here, and some of the people have joined virtually. I welcome all of you to this online training cum exposure series on black carbon measurement. We all know that air pollution, especially the particulate matter and the black carbon, is a major issue especially in the Indo-Gangetic plains. It's the main cause. Black carbon. When we speak about black carbon, there are very few major sources, as far as I understand. One is the consumption of coal at the thermal power plants. Another one is the burning of fossil fuels and the exhaust gases from the vehicles. And the third one, burning of agricultural waste and other waste by the common public. These put together has been a major problem addressing the air quality management in the state of Bihar. Especially, it is more pronounced in the Indo-Gangetic plains. There are some natural reasons for the accumulation of pollutants in the Bihar region, owing to its typical unique location in this geographical area. There are some man-made anthropogenic causes which has thrown us a big challenge to manage, and which is, I understand, that can be very well be managed with again human interventions. With this, I don't take much time. With this, I request our senior colleague, Dr. Naveen Kumar, to introduce our today's esteemed speakers. Sir, again, we are extremely elated to have you, both of you here, delivering the speech on this very valuable topic. Online training come exposure series is part of the public outreach attempt by the Bihar State Pollution Control Board, which we have started some few months back. And earlier we have already conducted 7 such monthly lecture series, some interactive series, scientific lecture series by eminent persons from IITs, NITs, and from the Delhi Municipal Corporation as well. The very objective of this sort of online training come exposure series is to make our colleagues who work here at the State Pollution Control Board to know about the latest technological developments and the research developments been going on around the world in the air quality management, monitoring of air quality. Especially, I would like to thank Dr. Deepankar Saha, who is the brainchild behind this online training come exposure series, because he's the one who is guiding us as a nodal officer here in the State Pollution Control Board about the air quality monitoring and its management. So with these few words, I request Dr. Naveen Kumar to please to introduce our esteemed speakers. Please, over to you.
Thank you, sir. Thank you. It's my privilege to introduce our resource persons today, 2 eminent scientists working in this field. So we are very happy that Dr. Safi Azhar from ISM Dhanbad joined us. He is an assistant professor working with the Environmental Science and Engineering Department of IIT ISM Dhanbad. Dr. Safi is a PhD and MTech from IIT Kanpur and has been a recipient of prestigious PhD fellowship from International Center for Integrated Mountain Development. His main area of work is based on aerosol fog interactions in Indo-Gangetic plain, that is very much relevant to us, and its effect on fine aerosol chemical, optical, and toxic property. We are very much happy to have you here, sir. A big hand I would expect for Dr. Safi, sir.
Thanks. Welcome.
Again, we are very happy to have with us Mr. Vinmoy Chakrabarti, who has took all pains to join us this odd hours for him, I believe. But anyway, sir, please, we are very happy to have you. Mr. Chakrabarti is a PhD scholar with the University of British Columbia. He is the Leo Scholar at the School of Public Policy and Global Affairs at the University of British Columbia. He is again an alumni of IIT Kanpur. Did his undergraduate studies in civil engineering from West Bengal University of Technology, Kolkata. His main area of research is scientific evaluation and application of low-cost sensors and micro thermometers in challenging environment. Sir, we do have a lot of problem in Indo-Gangetic plain with these aerosols. So we definitely expect your feedback on this very subject, and I'm sure that will benefit us, all our colleagues who are working on in this area. So, welcome. So, again, we welcome you, sir, with a big round
Thank
of
you. Thank you so much.
Thank you. Thank you.
So now, may I request first Dr. Safi to present his lecture.
So it will be alternatively. Minmoy will present. So we have presented our slides so that narration will be conveyed like that. So Minmoy
Okay.
will.
Okay, that's fine. That is perfectly
Please,
okay.
yeah, please go.
So may I request Mr. Chakravarti to please start with the presentations.
Sure. Before I start and share my screen, excuse me. I first would like to thank everyone who is present today in the talk, and Honorable Member Secretary, Dr. Shah, and members of Bihar State Pollution Control Board, Dr. Saifi Izhar, professors, scientists, and fellow researchers. I'm grateful to present my work and my opinions on microethylometer and how can we make better estimates of black carbon emission. And thank you for giving me this opportunity. So now let me share my screen. Okay, so are you able to see my screen?
Yeah, it's visible. Please go ahead. Yeah.
Okay, perfect. So today we are going to talk about black carbon measurement as a tool for aerosol apportionment, organized by Bihar State Pollution Control Board partner. And my talk will be particularly on black carbon measurement and what more we can do using ethiometer. So most of us, I believe, are aware of black carbon and its widespread impact, but it's still important to introduce the topic, why it is important. So combustion, as we know, which is a process of burning, and incomplete combustion can create carbon-rich soot particles. So whenever there is a process of burning, sometimes there could be lack of oxygen or low temperature burning, and which prevents complete chemical reaction, and that can actually create black carbon particles. So black carbon, or BC, has been identified as the second rank climate forcer. So which means that black carbon presence in the atmosphere could have a warming impact on climate, which could be 460 to 1600 times stronger than the carbon dioxide based on the age of pollutant. It has been also identified by several studies that black carbon is one of the toxic and health damaging pollutant. It can be a major fraction of fine particulate matter. I think most of us are aware of PM 2.5, which is aerosol particles less than 2.5 micron, and which can penetrate deep into our lungs and can affect human health. Wide range of health problems have been identified, starting from respiratory problems to cardiac problems, and as well as problem with memory and cognition to the children. In addition to that, recent studies have also identified black carbon concentrations can also impact the monsoon patterns. I believe all of us are aware of monsoon, which is one of the most important factors in terms of Indian agriculture and disaster management scenario. And because of black carbon, it has been identified that low intensity rainfall in pre-monsoon season has been found, and so as more cases of severe rain events. Several cases have been identified, particularly in northeast part of India, where Assam floods are more prevalent, and it is causing because of black carbon effects. So we understand that why and what are the impacts from black carbon. Now let us look at the sources of black carbon. So one of the major sources of black carbon, which has been identified by several studies and reports, is the usage of solid biomass fuel. So the image that you are seeing is one of the campaign we have performed in 2019, just before the COVID hit. And this is an image in a village in Uttar Pradesh. And we looked at how solid biomass fuel can actually emit black carbon. I will show you what are the results from that in the later slides. So this has been identified that solid biomass fuel, for example, dung cakes and firewoods, these are like one of the major sources of black carbon, which not only affects indoor air, but also outdoor air. In addition to that, fuel emissions from transportation sector, we are all aware of diesel vehicles and shipping emissions. They contribute a lot in terms of black carbon burden in the atmosphere. And finally, I also would like to talk about large-scale biomass burning. Here, the image that I'm trying to present is an effect of wildfires, which may not be prominent in terms of Indian scenario. But in India, we have something else that can be considered as a large-scale biomass burning, which are agricultural waste burning. And that has been in news across winter months, particularly in the Indo-Gangetic Plain, which is happening every year. So there are several techniques which are used to measuring black carbon. I am just trying to jot down and present to you what are the different ways of estimating black carbon. So the first technique would be thermal optical technique, which are used to measure elemental and organic carbon. The next could be photoacoustic technique, or the instrument would be photoacoustic soot spectrometer. And there are several optical techniques like particle soot absorption photometer, multi-angle absorption photometer, single particle soot photometer, and finally ethiometer. I am not going to in detail of all these instruments, but this is just to make you aware of the other instruments which could be used for measuring black carbon. However, ethiometer have been universally adopted, and especially by the regulatory bodies like pollution control boards and research group across the globe. And that's why we are not mostly focusing on the non-ethiometer approaches. We are going to discuss about ethiometer measurements. I highly recommend this paper if someone wants to read about what are the different ways of black carbon measurements and how we can report black carbon from different case studies. So before I go into the ethiometer and there are more details, I would like to first mention why the ethiometer has, or how ethiometer has evolved. So the word ethiometer came from this Greek word, which is called ethyle. So ethyle is a Greek term, which is around, I believe, 2,500-year-old word, which means blackened with soot. And in Greek theaters, black and white robes were used, and black robes were prepared by blackening the robes with the soot particles, and they were actually prepared for the theaters. So ethiometer word has been derived from this particular word, and that's why in 1984, Dr. Tony Hansen, who has published this phenomenal work, and where he introduced this instrument called ethiometer. This is one of the most cited papers where Dr. Hansen presents the way of measuring black carbon using optical absorption techniques. Here is the photo of Dr. Hansen. So in this photo, you can see Dr. Hansen is holding a small filter, and this filter he's showing, this filter has been taken in 1978. And using this filter, he started looking at black carbon particles, and from there he derived the ethiometer instrument. Yeah. So one of the other important thing is that even though this filter sample has been considered, has been taken in 1978, till now the filter remains. I think this is almost 40-year-old samples. So that's why everyone kind of considers black carbon as one of the persistent pollutants, which remains black throughout the time. So in today's talk, I will firstly talk about Ethiometer basics. Then I'll talk about Ethiometer operations, how Ethiometer works, and some of the artifacts that are present in Ethiometer, and there are how people are actually approaching towards correcting these Ethiometers. And I will show you what could be other or new generation Ethiometers, which could provide us better monitoring challenges, or which can help us addressing better monitoring challenges. So as we have seen that Ethiometer is one of the widely used instrument, but Ethiometer monitoring, or the way Ethiometer measures black carbon, is very simple. It's about how aerosol absorbs light with respect to time. And that's why it can be said as a simple and real-time instrument. But as and when technology has progressed, there has been like several complexities which have arrived, and people have generated more and more science. Usually, when ethylmeters in the ethylometer, when black carbon particles are collected, they are absorbed by light, and that particular light we call it as at IR wavelength, which is at 880 nanometer. So 880 nanometer light absorption can be used to estimate black carbon concentration. Recent days, there are multi-wavelength light absorption measurement techniques which could be used to facilitate source apportionment studies. For example, we can identify what are the different kinds of sources, whether it is coming from secondary source or coal combustion or biomass burning or so on. So these are more advanced techniques and could be used in conjunction with other instrumentation. And Dr. Saifi is going to talk in detail about source apportionment technique in the next presentation. In general, there are two types of ethylmeters. The first one is a single spot ethylmeter. And in the single spot ethylmeter, you can see that there is a light source, LED light source, and this light are impacted on a channel of filters. So light from the LED source pass through this particle loaded filter. So you can see this yellow box, which is the measurement chamber on which particles are loaded on the filter, and it is detected by these detectors, D1 and D2. So you can see lights are measured simultaneously in one of the sensing detectors and one of the reference detector. And based on that, we can understand what is happening, or how the light absorption is changing over the time. However, it has been identified that single spot ethylmeters are subjected to some errors, and that's why and most of the errors are coming from the like advanced identification of non-linearities in high concentrations. That's why dual spot ethylmeters have been introduced. In the dual spot ethylometer, there is no such change apart from there are three sensors. The two sensors are coming to two different spots, and one is the reference sensor. So if we look at here, there are two images, A31 and A33. A31 is one of the single spot ethylmeter, and A33 is a dual spot ethylmeter. You can see there are two spots on which a clean filter spot has been given, and over the time aerosols were deposited, and from there black carbon measurements were done. Few terminologies I would like to introduce before I go further. So first is I. I can be considered as the intensity of light measured by the detectors. Attenuation of ATN. Attenuation, it means the reduction of light by the sensors. And attenuation TH, which is the threshold attenuation value. A is the filter spot area. The filter spot I was showing you in the earlier slide, that spot. Sigma is a mass absorption cross section. It's a parameter which is dependent on the ethiometer that we are using. F is the airflow. So the air which is passed on the chamber, that is the airflow measurement that we use. And BC is the black carbon, and BABS or absorption coefficient. So I'm not going into too detail of BABS, but we will mostly focus on attenuation for now. So how ethiometer works? So ethiometer collects aerosol particles, as I told you, on filter continuously at a certain flow rate. It measures the transmission of light through the filter tip, and also there is two filter tape which are loaded filter and one is unloaded filter. That is a reference spot. So these are some equations which could be helpful for researchers who have been studying ethiometer. And in this slide, I'm going to show you like a sample way of how ethiometer works. So assume there are three spots: spot 1, spot 2, and reference spot. So these spots are at measuring I1, I2, and I0. These are like three detectors which are measuring the light sensors. And at time t1, we see that the attenuation measured is actually 0, which means these are clean. And now with respect to time, when we go, we see that the spot 1 and spot 2 are blackening, which means aerosols are deposited. Once it starts blackening, we see readings in I1 and I2, so as we get attenuation. And with respect to time, things keep getting blackened. And at certain time, we see that attenuation 1 reaches to 100. For example, if we assume the threshold attenuation value as 100, now what will happen? So there will be a filter spot change. So once there is a threshold which is set by the device, the instrument will jump onto the next spot, which means there will be another set of clean filter spots come, and then they will start measuring again. That is how we reach or we achieve a continuous real-time measurement of black carbon. So once filter spot changes, again, it repeats the same process. So we see another set of measurement like this, and so on. That is how ethiometer usually functions. However, ethiometers are not absolutely correct. There are certain artifacts in the ethiometer. One of such ethiometer artifact could be the loading effect, where black carbon concentration is underestimated due to increased particle loading. So for example, if we assume that there are layers of particles which are there, and on top of another layer of particle is coming, then the total absorption measured by these layers of particles will not remain same as the particle size increases. That's why a loading effect correction is required. And multiple scattering effect is another kind of correction which is required, which is coming from the light scattering. Remember, when any kind of particle interacts with light, there could be light absorption and there could be light scattering. Light scattering could be coming from particle itself, or also the filter substrate we are using. So that is considered as a whole as a multiple scattering effect. Now, this is one of the image I have taken from Maggie Scientific, who is the manufacturer of ethiometer AE33. So you can see that there are two spots taking measurements, and there is like raw BC1 and raw BC2 coming from two different spots, and from there, a compensated black carbon is estimated. So these calculations are based on heavy algorithms and all. Usually, we don't need to do these kind of post processing if we are using this as a monitoring or understanding what's the concentration range. But if there has to be any scientific development, then we will need to dig around algorithms which is used in these. So another recommended read. So this is one of the papers which is the backbone of AE33 measurement. So in this paper, they explain how dual spot ethiometers have been corrected, and particularly for the model AE33. So if any one of you are trying to work with A33, I highly recommend reading this paper, because this paper provides all the informations, theoretical backgrounds of A33 working principle. So I made a real-time visualization of ethiometer operation. So this is sample data from a study we did in Vancouver, where there was wildfire effects, and we can see how, with respect to time, attenuation changes, and as well as black carbon measurements are estimated. Okay, I don't think it worked, but let me see. Oh, I don't think it's working. Oh, sorry, I think it's not working for some reason, but I can explain you. So if you're following my pointer, so you can see that with respect to time, attenuation is increasing. When it reaches to 100, it drops down, and it again goes to a next filter spot. It keeps growing to attenuation 100, drops down, and so on. And at the same time, that the black, there is a difference in the corrected and non-corrected black carbon. That is why we need these correction factors. So you can also see that during the black carbon concentrations are very high. I even, like, in terms of Indian context, these concentration may not be too high. Remember, these concentrations are in nanograms per meter cube. However, in Vancouver's context, where the air quality remains almost every day is much better, I mean, almost clean air, for our scenario, this is like a severe pollution event. So in simple words, we see when increased attenuation, then we see darkening of the filter spot, and that's how. Oh, why it's not working? And when attenuation at particular time reaches attenuation threshold, the tape changes, and so as the ethiometer is going to measure with respect to time. In a polluted concentration, there will be a fast tape advancement, because aerosol, there will be high concentration of aerosol, which will drop very faster and make the sample very dark with respect to time. So the presence of loading effect can be very important, and there could be black carbon measured at very high concentration, but because of the loading effect, we may not achieve the level of black carbon which is actually present. That's why there are several ways to estimate this loading effect. One of the easiest way is to do a linear fit across the attenuation range and see if it remains same. Sorry, did I lose the internet connection?
No.
Yeah, just for a second only. I think just a second.
Okay. Are you still seeing my screen, or should I?
No, the screen is not there.
Okay, I can. Sorry about the internet issues. Okay. Yeah. So what I was explaining here is that how elevated. Sorry.
So
Okay, I think, yeah. Okay, so yeah, let's continue. So what I was explaining here is that how elevated concentrations can have different impact on the black carbon loading effect. So you can, so the blue line, so the blue line represents the cleaner days where there is very likely no black carbon concentration, which is like less than 2000 nanograms, and these are like elevated days coming from wildfire affected smoke. And you can see like instruments could be sensitive of the concentrations as well. So why am I particularly explaining this is because if we need to deploy instruments in setup like India, we might need to also check the performance of these instruments comparing to other filter-based measurement techniques. Then we can understand how these instruments are actually performing across highly concentrated regions. So here I'm showing you like the two instruments, AE33 and MA300. So you can see that microethiometer AE33, which is like very small, you can also put it in a hand. And ethiometer AE33 is like a solid instrument which requires additional power, and there are like other requirements for operating this instrument. However, AE33 is kind of considered as a gold standard for measuring black carbon concentration. So now I'm going to show you. In 2020, we did a comparison of AE33 and MA300, and I will show you some of the results from that, like how close MA300s are in comparison to AE33. So you can see this is like the hourly concentration of black carbon. Since black carbon is measured from ethiometer, sometimes they are also called equivalent black carbon or EBC. So EBC concentration, you can see they are pretty much falling on the same line, even if they are MA300 or AE33. However, we see that around 10% or 12% of underestimation, which is occurring in MA300. And I feel like this is within the reasonable range of adaptation. So once we know how the instrument performs, we can do some of this collocation and then kind of identify how the instruments are performing with respect to like a state-of-the-art instrument. So this is, I'm just showing you, this is like a paper which I have written, and this is under review. So the plot I have shown you is actually coming from this work, and I'm expecting it to publish very soon. So just a quick thought on why microethiometer. So microethiometers are portable and battery operated, and in operational point of view, they are like less logistics involved. They work on similar principle. These batteries can work for days. You just need to recharge and then again deploy, or also you can deploy when you are like when you can keep plugged in. Some other important thoughts are like example usage cases, which could be useful to regulatory monitoring. So if you're trying to look at microenvironmental and personal health exposure, what is happening to black carbon exposure to people who are cooking, in that case, this could be helpful. Or if you are trying to establish a monitoring network in indoor and outdoor environments, what Dr. Sao was saying. So I believe this could be one of the systems which we can use. And also we can keep a central reference system, for example, AE33, and we can periodically check the instrument's performance, if there are any. So I have prepared like a small-ish comparison table. So you can see that one of the major factors is that the weight of ethiometer AE33 is 20 kg approx, and MA300 is close to 700 grams. And I'm not going into too details of these operations, but just maybe one thing is, is that these instruments operate at very high flow rate, and that will require you to have additional pumps, and this can operate at very low flow rate and with the pump built in. To give you a perspective, I cannot give you like an exact price, but I can give you an idea. So the price of MA300 could be somewhere close to $20,000 US, and the same for AE33 could be around $80,000 US. I'm not totally sure, but I'm pretty sure like there is like around 1:4 ratio for these instruments. So this is one of the examples I wanted to share with you. So we measured black carbon concentration indoor and outdoor in rural households in Uttar Pradesh. So you can see that the black carbon concentration, and again, these measurements were done using the microethylometer. So you can see there is like a microethylometer, and also this white box is called RAM, which is like a low cost monitoring device. So we tried to measure use low cost techniques to measure the black carbon concentration and cooking emissions in indoor environments and parallelly at the outdoor environments. So we can see that the black carbon concentration could reach even 40 micrograms per meter cube. At comparison, in Vancouver, it was close to 5 micrograms when it is a very, very polluted day. So we can understand and feel like how bad the situations are in indoors. So I feel like this is provides us a great motivation to work together and provide us to help each other so that we can develop a better system of monitoring and as well as policy making. I would like to thank my supervisors, Professor Naomi Zimmerman, Professor Amanda Jiang, and my committee members, Dr. Steve Rojak, Dr. Milind Kandlikar, and Michael Brower, and my research group members from iReach and LEAP, and other funding members. Thank you so much. And if you need to contact me, here is my email. Thank you.
Would like to take any questions?
So now,
There is any question.
Mr. Chakravarti, will you like to have any questions right now, or we can discuss later on? If you are there, then.
Yeah, I think we can discuss later because I think Dr. Saifi is going to talk about like some related topics because these are fresh, and I think it will help us, to understand the topic. Perfect.
So you will be with us for some time?
Yeah, I am here.
Thank you. So now I request Dr. Saifi.
So let me share my screen. So is it visible? Like if you can confirm?
Yes, it's confirmed.
Okay, thank so thank you for inviting me, the representatives of Bihar State Pollution Control Board. It is an honor that you have provided a platform for emerging researcher. So I'm honored to share relevant works with regard to the topic that is being presented today. And I will also thank Minmoy. So I would just like to add just an extra information. We both were MTech friends. So that is where when Dr. Saha asked me, so I thought it would be better like if I can pitch him in. So thank you, Minmoy, for giving his consent and presenting a beautiful talk. So I will just carry forward from where he left. So as of now, he discussed about the Ethiometer working measurements. So I will quickly browse through the repeated things, and then we'll jump to the other aspects of Ethiometer that can be utilized in its application. So just to brief that, like when we are saying black carbon, black carbon is a portion of carbonaceous aerosol. So carbonaceous aerosols represents majority of the PM 2.5 or PM 10 fraction, and within that, black carbon is one of the most unique component because it absorbs the light completely. However, there is also another fraction of carbonaceous aerosol called brown carbon, which is a subpart of organic carbon, which also absorbs at lower wavelength. So if you see in the if you can see in this figure, so we have this three aerosol particle. One is white, which so whatever sunlight is coming, it scatters back. So these are mostly scattering aerosols. which are basically your major part of the organic and inorganic aerosols. While the middle part is the black carbon, which absorbs the totally the incoming solar radiation, and the other brown is your brown carbon, which is a fraction of organic carbon, which partly absorbs the solar radiation, and that too at the lower wavelength. So, so it is important that we need to understand the effect of carbonaceous aerosol on climate forcing and source apportionment. It is important to categorize them both, black carbon and brown carbon. And the reason being, these are widely being studied because because the uncertainty part in radiative forcing are very much high compared to their absolute value. While for the scattering aerosols, as of now, it is very much understood that the scattering phenomena of aerosols are largely being understood by the scientists working in that. So the focus is now to get more insight on black carbon and brown carbon, because they present most they are very much uncertain and they show variable values across the world. So as Minmoy said, like there are different absorption measurement techniques. So it can be categorized in terms of real time, or whether you are collecting in the filter based measurement and then characterizing with the this multi-wavelength carbon analyzer, which we call DRI model 2050. So all these measurements, so at the end we get the spectral measurement of the attenuation or absorption. So we utilize this absorption measurement values for black carbon and brown carbon apportionment, absorption apportionment, and further black carbon absorption can be apportioned to identify the contribution of traffic sources versus the biomass burning or wood burning sources. So to say like whatever absorption value we do get from this measurement techniques, it is not individually black carbon or brown carbon. We get for the total aerosol absorption values. So what I'm highlighting in this figure is that if you see in the x-axis we have multiple wavelengths, and in the y-axis we have the aerosol absorption value. So what we see is that the aerosol absorption values follow the power spectral law, meaning that absorption value increases as we move from higher wavelength to the lower wavelength. So and this spectral dependence is characterized by the angstrom absorption exponent value, which we call AEE value. So the AE value of the aerosol in the ambient condition varies extensively. Like it can range from 0.8 to 1.5 till 2. Like so, there is so much variation with regard to aerosol AE value. So so what is interesting is that, like qualitatively, we say that if the AE value of the aerosol is near to 1, then we qualitatively say that the absorption of the aerosol is largely contributed by the black carbon. However, when the AE value is further moved to higher range, like 1.5 towards the 2, then we say that the brown carbon dominance is there, additional to the black carbon. So that is why it is important to segregate the individual contribution of black carbon and brown carbon. So basically, this is the simplified two-component model, which is largely being followed in all the apportionment techniques. So it is like this carbonaceous aerosol absorption, what is being measured by the instruments. And then we do the arithmetic, like we try to identify the individual contribution of black carbon and brown carbon. So as of now, the largely followed approach is the extrapolation technique, in which what we do is that we say that at the higher wavelength, around 818 micrometer, we say that the absorption is largely being dominated by the black carbon alone. So whatever is the value we get, we apportion to the black carbon, and then utilizing black carbon AE value as 1, we extrapolate to it to the smaller wavelengths. And the whatever is the remaining value, then we attribute it to the brown carbon. So that is what we see. So this is the figure that we see initially, like this is the parent value that we get from the absorption techniques. And by utilizing this extrapolation technique, we segregate the black carbon and brown carbon thing. The main, however, there with the advanced statistical techniques, new approaches are coming across. So there is another way to apportion the black carbon and brown carbon, which is called statistical approach, which is basically defined by the least square optimization model. So in this, we do the optimization technique by utilizing the multi-wavelength absorption values, and we put this constraint. So from this optimization technique, again, we get the brown carbon and black carbon. However, the limitation of both of this technique is that the major assumption is that we fix the black carbon AE value as 1. So this can be problematic, like I will show with my PhD data results, like from where I get an idea to go for a newer technique. So so this is the experimentation data that when I was working in PhD. So if you see at this AE value that we observed for the winter time period we sampled, so the AE of the aerosol itself is lying lesser than 1. So it goes 0.9 until 0.9. So with this technique, if we try to apportion, so the value at the lower wavelength for brown carbon will be negative, because the underlying assumption here we are giving is that black carbon AE value as 1. So that is how this, whenever the AE value of aerosol is going to be lesser than 1, then this traditional way of apportioning black carbon and brown carbon will be giving meaningless result. So so that was the that motivated me to look for some advanced technique or to improve the apportionment technique. So what I did, like I went with this statistical approach, and in that rather fixing the value of AE black carbon as 1, I gave I constrained the value between 0.8 to 1.4, because this is known in the research community that black carbon AE value from different sources can vary between this range. So rather fixing black carbon AE value as just 1, I let the model choose whatever is the best optimized result. So by utilizing this, I did this, and the optimization model give very good correlation with the observed value. And further the question came, how do you verify this statistical technique? Because statistical technique is something that whatever you will do, it will give some end result. But you need to have some supplementary measurements so that you counter check that thing. So with parallel, what I had, like I extracted the water soluble brown carbon from the filters. So the water soluble brown carbon will always be lower than the total brown carbon that we are apportioning from this technique. So now, so for this, I compared my studies between BC AE equal to 1 and what I called the advanced technique. I termed it as AE optimal. So because that is a totally statistical approach. So if you look at the results in the left side, it is a technique based on using BCAE optimal, and the right side, which is your traditional approach by fixing the BCAE value as 1. So what you see in the higher wavelength for BCAE equal to 1, there are cases above 635 till 980, you see there is a brown carbon value also. By on the contrast with optimal this constraint, it is what we see that the brown carbon value diminishes beyond 635 nanometer. So that was one of the way to check the performance of the new method. And the second was like the we compared the total brown carbon absorption value with the brown carbon absorption value in aqueous extract. So the ideally the thing is the total brown carbon absorption should always be greater than the water soluble brown carbon value. So we got by using this optimal approach, this yellow color dotted line, this yellow color dotted represents the BCAE optimal data points, and we find that it is always higher than the water soluble brown carbon. While if you just go with the BCAE equal to 1 approach, then you see those data points where the total brown carbon absorption is lower than the water soluble brown carbon, which is meaningless. So that is why this improved approach can be further fit in the multispectral measurements to improve the segregation of black carbon and brown carbon. And one of the reason why this is this happened in Indo-Gangetic plain, because with the chemical characterization we found that the black carbon, the char type of black carbon dominates over the soot type of black carbon, meaning the biomass burning contribution is more compared to the vehicular emission in the Indo-Gangetic plain during the winter time. So that is why it is not convenient to use the traditional approach, which we call as AE value equal to 1. So I will just leave this. I will move to, so this is one of the paper that I published, the improved methodology. Like anyone have an interest to look deep dive, can look in this paper. So the other utility with the spectral measurements is to apportion the black carbon sources. And basically in urban or any region, we categorize the black carbon sources to be biomass versus traffic. So again, we utilize the spectral value, and these are the equations that we use. So in which by using this equation and the values of AE value for traffic and wood burning, one can get this kind of result. So with the total absorption value, one can for black carbon, one can further segregate the contribution of wood burning and traffic individually at different wavelength. So so how this ethiometer or multispectral measurement can be helpful in policy making. So one of the good case study that came out during the lockdown, and this is something work done during the lockdown period to see the effect of lockdown on the traffic contribution to the black carbon. So what we see, and this is for the New Delhi. So what we see in the x-axis is the timeline date, and in the y-axis is the BC concentration. And the pie chart have two color. One is blue, which is your black carbon due to biomass burning, and orange color due to black carbon due to fossil fuel. So before 23 March, which is called prior to lockdown or normal period. During that period, if you see, the contribution of fossil fuel was much higher compared to the biomass burning, 77% with respect to 23%. However, when lockdown was imposed, so we all know that during the lockdown, the traffic was curtailed off, very limited traffic was flowing. So this L1, L2, L3 are different lockdown periods. So you can see the very drastic change in the contribution of black carbon. Now the contribution of fossil fuel, which is basically vehicular emission, dropped to 51%. So, and it is consistent across until the lockdown, from lockdown 1 to lockdown 4. And as the lockdown was released, it came to the normal scenario. Again, the black fossil fuel contribution increased to 77%, very much in line with the prior to lockdown period. So this is one of the beneficiary of this spectral measurement can give for the decision makers, for the regional decision maker, in order to see whether the whatever the policy implication they are putting on is having some impact or not. So this spectral measurements and mainly the real time can be helpful in designing those kind of studies. Again, BC data can be clubbed in with wind velocity and wind direction thing to find out the local source direction from where that particular black carbon originated from is or being originated. And again, that can be even clubbed with the this long range transport thing to find out the how from where is the main origin of the black carbon, which where it is being basically being emitted, and to know about the long range transport thing. So these are, and so right now in India, the Ethiometer network is growing. So there are two agencies which are doing this extensively. One is called ARFI, Aerosol Radiative Forcing over India, which is led by Vikram Sarabhai Space Center, and they have currently deployed 35 ethiometers across India. And another is this National Black Carbon Network, which is initiated by IMD, Ministry of Earth Science. So as of now, 16 stations are deployed across the India. However, in the regional level, like within a city level, or if you want to assess the impact, whether with the policy making that you are putting in, whether it has any effect on the mitigation of black carbon or not. So this ethiometers, single ethiometers will not be enough to come to the conclusion. That is why the thrust moving forward is pitching to the low cost or micro ethiometers, which are one order lesser than the price of traditional ethiometer, and they can be easily deployed across the city to increase the monitoring and understanding the diurnal and spatial variation within the city. So the hour of the need is to go forward with this micro ethiometers, which I really believe not just in terms of black carbon, but again in terms of PM 2.5 or PM 10. Ideally, we can't go with the traditional way because they are too costly. So that is why this low cost sensors are coming forward, and there is significant thrust across the worldwide. So I will just conclude with this thing, that light spectral measurement instruments like Ethiometer is pivotal for understanding carbonaceous aerosol, and this measurement can be further utilized to apportionate the individual contribution of black carbon and brown carbon by using different approaches. And further also, black carbon can be further captured, like what is the local direction and how far it is coming from. And the future is about the low cost ethiometer, which we call mini ethiometer. If we really want to have a deep scientific approach to mitigate the concentration level within India. So thank you for listening. So we can open up for discussion if time is there.
Thank you, sir.
Thank you, Dr. Saifi.
Yeah, thank you.
So the floor is open for discussion. I will request the participants, if they have any queries, please feel free.
Request the online participants to raise any question.
I think chat box should
You can raise your hand. If any questions from online participants, please. Someone has posted a query.
yes. Okay. Doctor. So that has been addressed, I believe, by address. So any more questions?
Yeah, Rishi Balwant, raise hand.
Bolo. Rishi?
Balwant.
Hello.
Hello.
Sir, can you hear
Yes,
me?
sir. Bit louder. Little louder, please.
Okay. So, sir, actually, we are doing an internship at the IMD. So, one of our scientists, they have advised us to go through this session. So, sir, I just wanted to ask you, what are the key policy changes we need to bring about? Because I am also preparing for UPSC. So, I have key interest in this field. So I would want you all to just guide us कि मतलब ऐसा कौन सा पॉलिसी हम लोग इसमें ला सकते हैं जिससे कि कुछ चेंजेस आ सके, मतलब ऑन ग्राउंड सर फॉर रियलिटी, क्योंकि बहुत सारी पॉलिसी काम नहीं करती है, पर मतलब कुछ तो ऐसा बनाना होगा जिसमें कि सब लोग का मतलब जैसे स्टूडेंट, रिसर्चर्स, प्रोफेसर्स, एकेडमिशियंस, सब लोग काम, तो बस सर थोड़ा इतना ही जानना था।
Thank you very much for the question. Questions are always good. The thing is that I would like to inform to the entire floor that BSPCB is working with IIT ISM Dhanbad. They are on board. IIT Kharagpur, IIT Kanpur, IIT Delhi, IIT Mandi, both institute, and you are also representing IMD. And Shilpi, one of my colleagues, is there. She is now at USA. And my friend is Mrinmay, is at University of Columbia, and BSPCB is there. So there are 10 selected faculties are there in this group. And we are expecting 10 lectures. It is the first lecture only, background purpose, to set the tune for the other lectures, forthcoming lectures. So after 10 lectures, we will be in a position to come out with some sorts of policy, because apparently it appears that black carbon is a better tool, to my understanding. It is required to be proved with the data, with information, and at various levels, various depth, different seasons. Then only we may try to push this information at the national level. This is the main purpose. So that's why all 10 faculties and the entire group is chaired by our chairman, Professor Ashok Kumar Ghosh. He is there. Ultimately, please do join us at the panel discussion. Probably we'll be organizing after 3 months on completion of the 10 lecture series. So please, probably you are likely to get this information in the panel discussion itself. Thank you so much.
Yeah, Ms. Ritika, मैं यहाँ एक कुछ में आप जो पॉलिसी इंटरवेंशन का बात कर रहे थे कि ये जो है जो ब्लैक कार्बन रियली है, जो ब्लैक कार्बन है, ये रियली बर्निंग इश्यू है. ब्लैक कार्बन इज अ बर्निंग इश्यू. वो इसमें पॉलिसी इंटरवेंशन का अगर देखा जाएगा, ब्लैक कार्बन जब मोस्टली प्रोनाउंस्ड रहते हैं विंटर के मंथ्स में, उसका कुछ नेचुरल रीजंस भी है, कुछ ह्यूमन मैन मेड रीजंस भी है. जो नेचुरल रीजंस है उसको तो ज्यादा कुछ वो हम कुछ नहीं कर सकते, लेकिन जो मैन मेड रीजंस जो होते हैं उसको बिल्कुल जो है कोई मैनेज कर सकते हैं इजीली. उसमें जैसे गवर्नमेंट ने बायोमास, अभी जो ऑनरेबल स्पीकर्स दोनों ने जो उसमें एम्फसाइज किया था, यूपी में रिसर्च भी किया गया है डॉक्टर चक्रवर्ती द्वारा. वो इंडोर आउटडोर पोल्यूशन है, खास करके जो है डोमेस्टिक फ्यूल वुड जो यूज करके जो कुकिंग होते हैं, उससे वो बहुत ही अफेक्ट करता है हेल्थ को. उसमें गवर्नमेंट ऑफ इंडिया रिसेंटली जो है उज्ज्वला स्कीम लाया था, उसी तरह का क्लीन कुकिंग फ्यूल का वो प्रमोट करना चाहिए. इन वन गो वी कैन नॉट डू इट इन वन फाइन मॉर्निंग, वो दैट विल गो इन अ फेज्ड मैनर. तो उसका एक तो उज्ज्वला स्कीम लाया, धीरे धीरे स्मोकलेस चूल्हा टाइप का भी है, कुछ अटेम्प्ट्स होते हैं, और बायोगैस का भी बात चल रही है, वो गोवर्धन स्कीम भी अभी लाया है. इस तरह का जो है गवर्नमेंट ऑफ इंडिया का बहुत इंपॉर्टेंट स्कीम्स है. दूसरा उसके बाद दूसरा वो ऊर्जा गंगा स्कीम के तहत पीएनजी सीएनजी जो पाइप नेचुरल गैस, कंप्रेस्ड नेचुरल गैस का सप्लाई नॉट ओनली टू डोमेस्टिक सेक्टर बट आल्सो टू इंडस्ट्रियल सेक्टर का भी वो सप्लाई देने का काम चल रहा है. उसमें काफी अच्छा इंप्रूवमेंट्स है. लास्ट 2 years के अंदर हम लोगों का अभी करीब 60-70 सीएनजी स्टेशन आ गया बिहार में. इसके पहले एक भी नहीं था. और जैसे दिल्ली में क्या हुआ, इन वन फाइन मॉर्निंग सीएनजी में कन्वर्ट होना था, सुप्रीम कोर्ट का ऑर्डर था, तुरंत वो हो गया था, और सब लोग वो तुरंत दे फॉलो द डायरेक्शन ऑफ द ऑनरेबल सुप्रीम कोर्ट. और वहाँ उसके अनुसार का इंफ्रास्ट्रक्चर, इंस्टीट्यूशनल मैकेनिज्म, सब कुछ वो क्रिएट करने होते हैं, वो सब किया गया था. यहाँ हम लोग स्लोली किया गया था. ऑल ऑफ सडन करेंगे, बहुत उसका इकोनॉमिक फॉल आउट भी देखना पड़ता है, पीपल को बहुत हार्डशिप्स फेस करना पड़ सकता है। इसलिए वो जो है उसको धीरे धीरे से किया गया था, वो स्लोली लॉट ऑफ अभी तो ई व्हीकल्स का भी तो आ ही गया है, और सीएनजी व्हीकल्स का भी जो है प्रमोट कर रहे हैं, सब्सिडीज दे रहे हैं, इंसेंटिव्स दे रहे हैं। दूसरा एक इंपॉर्टेंट देखिएगा, इथेनॉल ब्लेंडेड पेट्रोल है, वो भी जो है इसमें पेट्रोल में कुछ वो हम लोगों का ऑयल, क्रूड ऑयल का इंपोर्ट पर मोर देन 60,000 करोड़ रुपीस का फॉरेन एक्सचेंज का बचत होगा, ये भारत सरकार का काम। तो इसलिए ईबीपी के तहत, वैसे भारत स्टेज 6 में है, 4 से 6 में आए हैं हम लोग अभी पूरा, तो अभी प्रेजेंटली 10% का ब्लेंडिंग चल रहा है ऋषिका जी। 2025 तक टारगेट दिया है ऑनरेबल प्राइम मिनिस्टर ने, इसको 20% ले जाना है। इसमें वो एथेनॉल ब्लेंडेड पेट्रोल का प्रोग्राम के तहत अभी बहुत सारे ग्रेन बेस्ड डिस्टिलरीज को बढ़ावा दी जा रही है। इतना दिन से मोलासस बेस्ड था, अब होके वो जो है बहुत सारे एग्रीकल्चरल पोस्ट हार्वेस्ट में बहुत सारे एग्रीकल्चरल प्रोड्यूसर्स, ग्रेन्स है, फ्रूट्स है, ये सब वेस्ट भी होते हैं, उससे सोर्स करके वो अल्कोहल प्रोड्यूस करेंगे, जो एथेनॉल एक्सक्लूसिवली एथेनॉल ब्लेंडेड पेट्रोल प्रोग्राम में जाएगा। दूसरा व्हीकल स्क्रैपिंग का भी जो है आज का हेडलाइन भी है कुछ न्यूज़पेपर्स में कि व्हीकल स्क्रैपिंग है, जो 15 इयर्स ओल्ड ऑल गवर्नमेंट व्हीकल्स विल बी स्क्रैप्ड। इसके लिए सेंट्रल मिनिस्ट्री के डायरेक्शन पर स्टेट ट्रांसपोर्ट डिपार्टमेंट्स व्हीकल स्क्रैपिंग फैसिलिटीज को क्रिएट किया है। ये बहुत कम समय में ज्यादा फैसिलिटीज अभी है। दूसरा है, हमको एक मेजर जो देखा जाएगा वो हम लोग का एनर्जी सेक्टर है। एक ट्रांसपोर्ट सेक्टर तो अभी हम इतना देर बात किया था, एनर्जी सेक्टर है। एनर्जी पर हम लोगों का जो है रिन्यूएबल एनर्जी पर वो धीरे धीरे स्लोली ट्रांजिशन हो रहा है, और थर्मल पावर प्लांट्स अभी भी मेजोरिटी हम लोगों का है कि वो कोल बेस्ड थर्मल पावर प्लांट्स है। एक तो वो एटॉमिक पावर प्लांट्स भी है, रिन्यूएबल एनर्जी भी एक ऑप्शन है, बट वो कोल बेस्ड थर्मल पावर प्लांट्स का इमिशंस अभी एक मेजर इश्यू है। प्लस हम लोग का दूसरा एग्रीकल्चरल वेस्ट स्टबल बर्निंग है, एग्रीकल्चर वेस्ट बर्निंग एक मेजर इश्यू है, इसको एड्रेस किया जा रहा है थ्रू वेरियस इंटरवेंशंस ऑफ द गवर्नमेंट। और थर्ड सेकंड एक लार्जेस्ट कोल कंजम्पशन कोई सेक्टर करते हैं तो ब्रिक सेक्टर, ब्रिक किल्न सेक्टर है। जो रेड क्ले ब्रिक्स है उसको हम लोग विसाविस द फ्लाई ऐश ब्रिक्स, some 10 years back there were only 2 such fly ash brick making units in the state of Bihar. Now we have more than 400 fly ash brick making units in Bihar. तो इसका रेड क्ले ब्रिक्स में जो है मेजर जो फ्यूल यूज की जाती है उसको कोल, सो और अपार्ट फ्रॉम दैट वो उसका वो हम लोग का टॉप लेयर का सॉइल, फर्टाइल सॉइल को भी कंज्यूम करते हैं। ये सब चीज है, इसको फ्लाई ऐश को मोर इको फ्रेंडली माना जाता है। ये सब चीज है सम ऑफ द इको इनिशिएटिव्स, पॉलिसी इंटरवेंशंस ऑफ द गवर्नमेंट। ये सब चीज पर आप थोड़ा सा आप ग्रुप डिस्कशन करिएगा तो कुछ और न्यू आइडियाज, कुछ न्यू पॉइंट्स भी आपको आए। Thank you. Over to the speakers and the participants. Any more questions, please?
Mrinbhai, I have some 2-3 basic questions.
Board analyst want to give his comments on this.
Yes.
Arunji, please.
Please.
Just a quick thing here. I think Dr. Kriparam has also raised his hand, so maybe can we address his question first?
Yeah, sure, please. Yeah. Please go ahead.
Yeah, Dr. Chakravarti and then Dr. Saifi, it was a good lecture. Hello, can you hear me, please?
Yeah, we can hear you. Thank you.
So this was a very nice lecture and mostly pitching towards this, like, using more of thermometer. But my point or concern is we now have so many measurements and so much measurements of black carbon across India, and still we are proposing many. But the point is that just measuring has not helped either in reducing the pollution or getting the sources right. So it's just technological advances that we have. What I feel, unfortunately, that the most of the technology or the instruments that we use today, they are actually like they have been quite extensively used in developed countries earlier, like USA, Germany, and then other places, and then it came back to India. This is really very unfortunate. Although I like this one, I started a lot of research on black carbon, but what I feel that the research on black carbon measurements is almost like, has reached the stagnant level. There are not much things that are either coming in terms of more of research, neither in terms of research nor in terms of policy recommendations. I would, of course, it's always good to have lots of measurement, but then the point is that what is the outcome of those measurements, right? So this one point. The second point, it all started when we started doing aerosol research, and then India was blamed to be, producing lots of fossil fuel emissions. And we were, early 2010 or 2000, we proposed that India, based on lots of molecular markers, we said that India is putting not only the fossil fuel, but it is mostly dominated by biomass burning. Okay, so this was then later accepted, and then this was further confirmed with the carbon 14 measurement. Now, with the lots of such measurements that we already have, I think we need to work on the mitigation strategies rather than more monitoring also. So this is my thought. You may just like to say, or we can start working on together on this line. Thank you.
Board Ministry.
Now, our board analyst want to give some few comments on the question raised by Rishikesh. Please, over to you.
थैंक यू सर। ये पॉलिसी इंटरवेंशन का बात जहाँ तक आता है, तो जब कोई भी पॉलिसी जब बनेगी, जब उसका स्टैंडर्ड्स आएगा, और अगर पहले देखा जाए 90s के पहले का, तो 2009 के पहले का, तो उस समय SPM स्टैंडर्ड में था, सस्पेंडेड पार्टिकुलेट मैटर, और उस आधार पर बहुत सारे पॉलिसीज थे। धीरे धीरे रिसर्च आया, उसमें हुआ कि नहीं, पार्टिकल साइज का डिफरेंशिएशन होना चाहिए, तो पार्टिकल साइज का डिफरेंशिएशन किया गया PM10 एंड PM2.5, सो दैट कि जब रिसर्च हुआ कि 10 माइक्रोन से नीचे के पार्टिकल रेस्पिरेटरी सिस्टम में नहीं जाते हैं, तो व्हाट इज द जरूरत क्या है कि PM10 से ऊपर वाले को रखा जाए। अब धीरे धीरे रिसर्च बढ़ रहा है एयर फील्ड में। अब ब्लैक कार्बन अब है कि PM10 और PM2.5 में भी सारे पार्टिकल्स जो है वो हार्मफुल नहीं है। खासकर जब ब्लैक कार्बन की बात आती है तो ये काफी हार्मफुल है। तो इस तरह के रिसर्च और जब स्टडी होंगे तो आने वाले समय में ये ब्लैक कार्बन के भी स्टैंडर्ड्स हमारे जो क्राइटेरिया पोल्यूटेंट है उसमें आने की संभावना है। जब ये क्राइटेरिया पोल्यूटेंट में आ जाएंगे तो इसके आधार पर बहुत सारे पॉलिसी जो है डेवलप करेंगे और एयर को बेहतर बनाने के लिए जरूरी होंगे। थैंक यू।
बहुत अच्छा।
चेयरमैन साहब नजर आ रहे हैं क्या? जी।
Someone has raised this.
कौन है? हैंड रेज किया हुआ किसका है?
मंटू कुशवाहा।
मंटू कुशवाहा, अब बताइए।
Sir, good afternoon, sir. Good afternoon to everyone. And my question to Dr. Saifi, he is going with this black carbon, right? And there is lots of product on satellite-based data like AOD, as well as many characterization of particulate matter. So why he is going with black carbon? My simple question is about he is further going with black carbon, but further there is also lots of characterization of particulate matter, right? And there is lots of health issues regarding this particulate matter. Also, I have read one article on Times of India newspaper about the COPD on basically on Patna. So can you clear about this, to Dr. Saif?
Could you introduce yourself, please?
Yeah, I am currently pursuing my MSc from Environmental Science from Central University of South Bihar, and I am currently working on aerosol optical depth in my dissertation and COPD-like diseases, like global warming disease.
Thank you. So, Dr. Safi, please.
Yeah, so Mantu, so this is not like because the topic of the discussion is black carbon, so we have presented on black one. Means nowhere we deny that black carbon is only responsible for the health effect. All the other chemical components, be it organics, be it inorganics, be it metals, be it pHs, all are known for harming the human health. However, like the main discussion for today's theme, what are the advances in terms of black carbon and brown carbon monitoring? Like how do we get to more true value of this black carbon and at a local level? So that is why the future is going towards this low cost black carbon or low cost monitor, because those are easy to be deployed, those are easy to be data can be easily available, and in the ground one can see the impact of the policy making. So I will just add what Dr. Kriparam said. Like we do know this chemical and all this properties of the aerosol. The main challenge is we are not seeing the implementation part. So that is the missing thing. Like and how so whenever say any implementation thing will happen, so we need to be scientific whether that implementation policy was successful or not. So in that way, when we are implementing our policy, we also need to monitor, because monitor that thing can only verify that whether your implementation is successful or not. So with regard to monitoring the this concentration level, you can't deploy the high costly instruments everywhere. That is why this sensor works are coming forward, because those are low cost. And if the confidence is gained that low cost sensors also replicate well with the standard instruments, so that can be more easily deployed and it can be beneficial in checking the implementation part, how much implementation has been successful. So that is what like I will just answer both the things.
Dr. Safi, if you please permit, may I just supplement?
Sure.
The thing is that if you particularly the question raised by the South Bihar University scholar, that all our action plans, if you see any action plan, air pollution prevention action plan, all are related to mostly complete combustion, number one. Number two is the clean fuel. Number three is technology improvement. Number four is proper energy consumption. So all our action plan is targeting towards optimum use of carbon and nothing to go into the atmosphere as black carbon, because black carbon is pure carbon. Pure carbon is the energy. So energy should not be spoiled. So if we target black carbon, our efficiency at the city level or at the level, we can verify ourselves easily whether we are discharging carbon into the atmosphere or not. Besides health impact, we can judge ourselves by monitoring and measuring black carbon as a parameter throughout the year. Because we are, particularly India is tropical country, and dust we cannot avoid. And all the time the dust cannot be comparable. It cannot be a common parameter for all. So we are just discussing these issues if this can be used as a tool for our effective management of air quality in the air. That is the basic purpose.
One question from Murthy.
Murthy, please.
Good morning. I'm Murthy Nair, the program lead to the program management unit at Bihar State Pollution Control Board. And first of all, I would like to appreciate both the eminent speakers for a well-structured presentation. And my question is, so it's been over 3 years that we are implementing this clean air action plan in 3 cities. And talking about Patna in terms of transport has taken a very good interventions. They have actually banned entry of diesel-driven auto rickshaws and commercial vehicles within a vicinity of somewhere around like 140 square kilometers, roughly. So using this traditional method of monitoring, CAQMS, it's a cumulative value, so we don't see much of improvement. Now, from the policy level, we are supposed to take a moment and convince the respective department for the interventions they have done. But since the improvement in air quality is not shown by the CAQMS, we need to come up with something alternative. So talking about ethiometers and knowing about the status of the entire geography of IGP plane and the transport of, the transport of pollutants, how can we use this ethiometer in terms of monitoring what improvement just in terms of transportation? Is it possible, as in you have mentioned, brown carbon and black carbon can be segregated? Can we further segregate this black carbon into different sources, take an example, transport, industry, or any other related? And we can take a moment to say, yes, this policy level intervention of yours has actually improved this much of air quality. So is that possible? I'm actually talking from the context of Bihar, knowing the geography and all other aspects, please.
Yeah, definitely. That is the utility of this ethiometer or mini ethiometer, because this mini ethiometer earlier used to be only dual wavelength or single wavelength, but now this micro edge that my fellow colleague has presented, it is coming with 5 wavelength. So whenever we have more wavelength, then we can categorize the sources of black carbon into a vehicular emission and biomass burning. So that is definitely with this data you can do at the city level, definitely. Like further, if you want to improve like more segregate with regard to more diverse sources, then we need to go through this filter based PMF and all those CMB modeling. But yes, with this micro edge, one can definitely categorize the contribution of black carbon with regard to vehicle and biomass burning at a city scale, local scale, wherever you are doing. And it is that is why the motive is like you can't purchase ethiometer for all the sites where you want to see, because one ethiometer comes say at least 10 times or 5 times higher than the micro edge. So at that, say if the unit of ethiometer is 30 lakh, then at that same amount you can purchase 7 to 8 micro edge, and you can deploy within the city to see more detailed information about the contribution level of vehicular emission with regard to biomass burning. And with additional filter based technique, you can obviously increase the source apportionment detail.
Good. Very good reply. Very good. That is, we also discussed, Murthy is my colleague. Because we are sitting together and keep on discussing all these issues for local issues, how can we resolve. So one thing, if you please permit, we have exceeded. One thing you will please made my one thing you will please permit. 3 things. One is that whether the world is having EC standard. Number 1 is the ambient air. Number 2, what our board analyst has also wishes to wanted to know. Number 2 is the calibration, because Midbhai was talking about the 12% error in the data, and he has discarded. And Saif also told the AE value between 0.8 to 1.2. You have the corrected factor. That is the beauty of his work. I must appreciate the materials and method is very important. That's I keep on telling all my young people. Focus on the materials and method, what you are given. So 3 things I just wanted to, and last question to not a question for a discussion. Whenever you are talking about the sensor means, and there are differences between analyzer and sensor. Micro sensor, could you please elaborate this word? Because sensor, I have some allergy, openly telling, because of its erroneous results. So please, micro sensor, what is it going to do? Is it the A30 or A33 or MA300, and you spoke about sensor. What are these three different issues?
Yes, great question. I can understand, like, in terms of like a scientific point of view, we can have a different understanding of how a pollution monitoring instrument could be, or in terms of community science or community development, how an instrument's perspective will be. So usually, I would say mostly whenever we think of in terms of an instrument which is of gold standard, which has been universally accepted and which can provide us most of the scientific understanding of how this instrument works, and if this instrument could be used in multiple locations, and at the same time it could replicate the study, I mean replicate the concentrations whatever we are getting, we could consider them as an analyzer, like an instrument which is capable of reproducing the data with a basis of concrete science, right? But when we talk about sensors, so sensors, I would say, is like a newer term which is used in this community, the science and policy community. So the usage of sensor came when we are in short of regulatory monitoring stations. We cannot provide monitoring stations across every junctions or every household. So that's why sensors are being developed, which are low cost and cheap. However, the Saifi, whatever the sensor he was talking about, that could be a low cost sensor. And MA300, the one that I was talking to you, I was explaining you, that is not a sensor, that is micro ethiometer. So micro ethiometer and ethiometer, they work on same principle, but it is called micro because of its small form factor, and which is portable and can be used in, in segments where you have challenges in monitoring. But both the instrument work in similar principle. In terms of calibration, your second question. So I think I answered your third question first. So let me go to the second question. In terms of calibration, yes, I feel like calibration is a very important aspect of using such instruments. And since we are aware of A33 as one of the gold standard, so the way usually we call we do calibrate using our instruments, or like any comparatively cheaper instrument, is to compare each other when we keep it at at a particular station. So for example, I can assume, like, if you're buying 5 micro ethiometers, and if you have already a station where you have a A33 or gold standard ethiometer, you can keep those instruments at the same location. Ideally they should measure the same, right? But they wouldn't, because of the instrumental sensitivity or how they would perform. Based on that, we can identify like how these instruments perform and what are the uncertainties. Once we know the uncertainty in the instrument, then we can actually convey that even if we measure the concentration, for example, we are measuring 40 micrograms per meter cube, but we know it's 40 plus minus 3 or 2, so which is again a good knowledge to go further. That's the part of calibration. And I think your first question was about standards, right? Yes. So
ambient air quality in the entire globe.
Sorry, I couldn't hear you.
Ambient air quality standard on BC adapted by any country in the world.
Yes. So this is a challenging question, I would say. So how it happens is that there has not been a consensus of black carbon standard, because black carbon measurement itself highly uncertain. So I would like to take the point what Dr. Kriparam mentioned in his comment, that we have lot of measurements across India and across globe. However, what I am trying to highlight is that the measurements may not be representative of what we are seeing or what we are actually observing in macro to micro level. So in micro conditions, for example, somewhere, what is exactly happening in the tailpipe emission of a vehicle, or what is exactly happening at the household level emission. So those measurements have a lot of uncertainty, the uncertainty which I was talking to you. Since we have a lot of uncertainty, that's why there are studies like Safi and other people, even Dr. Kriparam, and I am aware of Dr. Verma from IIT Kharagpur. She has also done like excellent modeling studies where they are actually looking at like what could be like a policy intervention and how it could help us reduce cardiovascular disease burden or like any other disease burden. So all these are dependent on studies where we have measurements, and those measurements are again have uncertainty. So this is universally done, and the science of black carbon estimation is not complete, I would say. It's not like something we have learned about PM 2.5. We know that PM 2.5 measurement is possible, but if we are trying to use very low or cheap quality black carbon sensors, like I'm aware of, there is one sensor from University of California, Berkeley. So they have ABCD sensor. They call it ABCD. I don't remember why they call it ABCD, but ABCD is like low cost black carbon monitoring sensor. And that is used and deployed in California in several locations by a very eminent research group. And they have been working around it, and they are still trying to develop the science. So the science of black carbon is still under development. Like Safi has developed an optimization statistical based techniques, and like the way people are developing, and we need data to get more confidence on what we are measuring. I feel that's why we don't have any consensus on BC standard so far.
Thank you. Thank you, Vanmaji. So let us give a big hand to both of our resource persons for the very detailed presentation. May I request all our online participants to get their cameras on for having a photograph.
Can you please switch on your video camera so that we can take a group photo, please? Okay, go ahead.
Go ahead, take the screen.
So now, coming to the end of the program, may I request our member secretary, sir, to propose a vote of thanks and announce the announcement and make the announcement for the next lecture.
Yes.
Sir, please.
Thank you, Dr. Naveed. So it was a wonderful and a structured and informative speech by our eminent speakers, Dr. Saifi Izahar, IIT Dhanbad, and Mr. Mrinalmay Chakrabarti, University of British Columbia, Canada. It was really an eye-opener for me, like a non-technical person like me. But I could able to see a lot of IIT professionals from IIT, from other reputed educational institutions have also participated through virtual mode. This is really a very helpful and a very informative lecture by you. This will help us and all our colleagues to venture more deep, take a deep dive into this black carbon measurement. Of course, today's topic is all about the black carbon measurement, and this is a part of this is a two-part series. And today's is the first part, which is about the black carbon measurement as a tool for aerosol apportionment, and the part two will be about brown carbon and data application in aerosol apportionment. And this lecture will be delivered by Dr. Sanyantan Sarkar and Ms. Supriya Dey of IIT Mandi. And the next lecture will be training cum exposure series lecture will be on 10th of February 2023 at 2 p.m. So actually, I strongly believe that what is measured can be managed. Unless we quantify anything, we cannot prove what intervention, the success of any policy intervention. So this sort of quantification or monitoring of pollutants really supports the policy interventions, the policy frameworks of the government, and will strongly support the people welfare accordingly. So with these words, I once again take this opportunity to thank our respected speakers for the today's lecture series, Dr. Saifi Izagar and Mr. Mrinalay Chakrabarti. Also, I thank the brainchild behind this initiative, Dr. Dipankar Saha, who is nodal officer here with NCAP program with our board. Also, I thank all my senior colleagues, our board analyst, Mr. Arun Kumar, Dr. Naveen Kumar, and all my colleagues who have joined physically, and also all the respected participants from various reputed organizations from throughout the country. Thank you, one and all. Good day. Namaste.
Excellent. Thank you.
Murthy?
Thank you.
Thank you so much.
Thank you, Tom. One of the
बहुत अच्छा पार्टिसिपेशन।